Hi there, Team MAI here again. In this video, we would like to show you how we use the camera to calculate the position of all visible tokens and robots inside the arena. Once again, we're going to use these variables, of which we already used some in the last video. Now then, in the last video, we looked at this robot picture and we reduced it down to its important bits of information. We're going to continue using this picture, so let's get right to it. To start off, we will have to create two new classes. The first one will be called Token. It stores the vision marker from the SR library, its position inside the arena, the direction from which it was seen, and its type, meaning A, B, or C. Its constructor sets all these variables based on its parameters. With some help from the global variable token width, it also calculates the center of the token if the variable token marker direction is set to middle. This is done because the marker is not actually the center of the token if the token was seen from the side. If we run it, we can create an instance of token. The second class will be called OtherRobot. Like the first class, it stores its position inside the arena. In addition to that, it also stores the robot's corner. The constructor just sets all these variables based on its parameters. Running this creates an instance of OtherRobot. Now let's get back to last video's coordinate system. Using all the token markers and some basic trigonometry, we can figure out the position of any marker inside the arena. By adding center.polar.y to our arena angle and using the dot distance attribute as our hypotenuse, we can calculate the relative distance of the marker to our robot, with cosine standing for relative x and sine for relative y. Then we just add these relative values to our absolute arena positions to get the absolute marker positions inside the arena. Here's also where we determine whether we're looking at a token from the top or from the side, depending on how much it's tilted. In the end, the method just returns all the accumulated information in the form of 4 arrays, all ready to create an instance of the token class. So let's run it. Now we just have to do the same thing again for all robot markers. The difference here is, though, that we don't have to differentiate between a token seen from the side or from the top, since all robo badges are mounted from the side. Like the last method, this method will return just 4 regular arrays. But since our example does not include any robot markers, running it will not change a whole lot. At this point, we have 2 classes and a bunch of arrays filled with information. We now just need to create some instances of those classes using that information. The method makeTokens does exactly that for us. Only in addition, it also deletes all tokens that have the same .info.code as any of the previously saved tokens. Why do we have to do that? Well, we have to do that because if we see a token from 2 sides, meaning 2 markers, we only want to save one of those markers as a token because there cannot be 2 tokens in the same spot. Before it's done, it also deletes all markers that are already saved in the secured tokens integer array. We'll do that because we don't want to pick up tokens that are already secured. If everything goes according to plan, we can turn a bunch of numbers in a coordinate system into a nice token. Make Robots works pretty much the same way, only for robots, and it doesn't store at doubles since we don't care if there are 2 robots in the same spot. Like makeTokens, when running it, it can turn a bunch of numbers into some nice instances of OtherRobot. Last up, we also created a method called updateTargetingToken. Targeting is our global variable that we use to save the token that we want to pick up next. And even though our positions of the tokens are based on the arena and not the current position of the robot, it still makes a lot of sense to update that token whenever possible. The method itself just goes through all tokens and looks at if any of them has the same .info.code as the targeting token, and if it finds one, it just overrides the targeting token with that token. After running this, we now finally know the position of all tokens and robots visible to the camera, and we can use that to pick up tokens and avoid other robots if we want to. Now, that's pretty much it for this video. Good luck and happy coding!